Hey, can I ask a question?
Yes.
Laura, so your shear wall study pretty interesting. Huh? I had a couple of questions. One is you mentioned confined concrete properties. Are we talking about um, you know, the panel itself? I mean, or how do you go about determining the confined properties in the main panel, not the end sections? Huh? I mean, what kind of? I mean, I've really
In
not
the
seen.
main,
Yeah, because you essentially have maybe two
so we're
layers.
not using the,
Hello?
yeah, I'm sorry. I think there's a bit of a delay.
Oh,
We're using only unconfined concrete in the interior of the wall
okay,
and
okay.
only using the concrete layers in the boundary elements.
The boundary element, got it, yeah. Another quick question had to do with, I mean, I remember looking at this layered element a while ago. I thought both the transverse and longitudinal steel in this model were smeared, but you seem to indicate you're going to actually use truss elements for your longitudinal steel. I'm wondering how that fits in with his model. Huh?
His model is really just in my mind, the concrete constitutive model that fits into this layered shell.
Ah,
And it doesn't make sense to me to use the smeared vertical reinforcement in the boundary element because you really want all of the steel area at that particular point.
mhm.
And I think we will investigate using smeared vertical reinforcement in the interior of the wall, where you'd have obviously less reinforcement in that approximation may not be so critical. But thus far, it seems to be working fine using the truss elements in the boundary element with
Okay.
smeared vertical steel.
Okay, got it. So the truss elements you're talking about is in the boundary elements only, not,
Yeah.
okay. Okay.
Right. Do we have any questions for anyone?
Yes, Amit, Boris here. Was that your picture on the front? Never mind.
Which where?
There was a picture. I think it was you from many years ago. Your front picture for the Zoom.
All right. Okay. Well, I guess I'll take a picture from many years ago then from now, as would most of us. Any other questions, thoughts? Yeah. Maybe it was just a picture from before COVID. So yeah, which is when we were all younger. So all right, so I think we have a good 10 minutes left over. So I don't know what you have planned, but you can do that for 10 minutes more than you were going to do earlier. So, so thank you everybody for your talks, and see you in, I don't know, 40 minutes or something. Amarnath, do I need to do anything else, or are we good?
No, we are good. Thank you.
All right, thank you. Bye-bye.
See you.
Sashi, do you have time to talk about the?
Hmm?
Do you have time to talk about your bar element?
Oh, okay, yeah. So we are actually just using a hysteretic material right now. I'm not using the reinforcing steel material that
Okay.
yeah, because, we had some issues with that, especially the fatigue part. And so we are really post-processing, with the hysteretic material, we're able to have, we're able to incorporate softening on the compression and tension side. So essentially, we essentially introduce softening once the bar buckles, and so all you need is a buckling model to determine when your bar is going to buckle. Huh?
Yeah, we've been pretty successful using the min-max wrapper and just dropping the reinforcement when the compression strain in the steel hits the same strain as when the concrete loses compressive capacity.
Yeah, yeah.
And so basically just saying that if the concrete is completely gone, then the steel is going to buckle and lose most of its capacity.
Mhm.
But there are more sophisticated buckling models than what we've been doing. And so I'm just curious about, your thought. I was curious about your thoughts on using something more sophisticated to simulate the actual buckling.
Yeah, so, and I just saw this message from Amarnath. So we are still part of the panel. Like, is this being recorded? I mean, do you want to schedule a time offline? I mean, we can send an email and chat about it.
Yeah.
I just wanted to remind Shashi, that's all. Yeah. Farzin has a question. He raised his hand. Farzin, do you have any comments?
Yes, I'm very interested in what Sasha and Laura are talking about.
Okay.
And the point that I'm interested in asking a question today is how much longer would it take to run a single column going through all of these detailed modeling approaches compared to just Stilo 1, Stilo 2, and Concreto 1?
We're talking about like a finite element, detailed finite element model.
Actually, your model makes a lot of sense to me, Sashi.
Yeah, but that's still a very simple,
Yes, it's still simple, but going through the min-max wrapper and the hysteretic model, going through all of that increases the time, let's say from 5 seconds for each ground motion to maybe 7 or 10 seconds for each ground motion.
Yeah, that's about it. I don't think much more than that. Huh?
But that is doubling the time for the total analysis, which if it's taking 1 month to do all of the work that we are doing, that will make it's going to take 2 months to do all the work that we're doing. So these tiny increases in time to run might sound minute when you're talking about 20, 40 simulations, but when it comes to million or 2 million simulations, then it's going to add up and be a big number.
Yeah, so I mean, I would say that doing so-called detail, if you want to call the model that I had detail, that's just a way to come up with your kind of base capacity limit states, right? So you don't have to do this for a million columns. You just have to do that for classes of columns, and I think that's not that time consuming. I mean, if you're talking about the TINA or finite element models where you're modeling every bar, and the mesh and some of the things that even Laura was talking about, I mean, those things can get really time consuming. But these details are very important if you really want to capture, because these are important damage states, the buckling of a bar, and when the concrete crushes in the core and you essentially expose it, and you get failure. So trying to capture those very particular limit states, I think you need to put in a little bit more effort that both your core concrete model and your steel models are able to capture some of that.
Yeah.
I guess I would say, kind of following on, that this is research. And so if it's going to take twice as long, that's okay, because the end result is that you can tell people that they should do this or that. And then when they go to do it, they're not doing the same number of simulations. They're only doing a few simulations, but they need the accuracy of simulating the onset of strength loss due to one of these mechanisms. And they're probably only doing, I don't know, a dozen or 2 dozen. The next step then would be to say that they're kind of what Sashi's doing is just here's the limit state, and you can expect that limit state is going to be reached at whatever you're using as your demand variable, whether it's strain on a section or it's drift or it's whatever. I'm not sure, although now that some of these data sets are very, very large, maybe there is that option of taking that next step of having meta models.
No, you're right. Yes.
Sure. Again, I'm here just to hear your advice. So thank you very much for your input, guys.
Yeah, and Laura, so I think offline I'll send you an email or something, and we can set up a time to just generally chat about what you're doing. And because I also currently have another project in which I'm looking at shear wall buildings. So I'd like to get something from your experience with using this.
It looks like Salim Gunai has a question, so we can.
Yeah, I'm here. So, yeah.
Have a question.
Salim, go.
Oh, sorry, I was
Yeah,
muted.
you're muted.
Yeah, actually, Professor Kunal, we used the reinforcing steel material without problems in a recent column model. But now, since you mentioned you are using hysteretic, we'll also try that, I would say. And so actually, I had a question about that, like the post-buckling slope. Did you just adjust it to match the test results, or was it based on some particular material test results?
Yeah, no, this is based on some work that a former student of mine did. I cited that in my thing. I can send you the link. Of course. So it's a full a trilinear model. So it goes. We assume that the buckling happens at the at the yield point, and then we had done a whole bunch of simulations to kind of capture the slope after that. Huh? So it's based on a model. So it's not just it's not just simply to match experiments.
Oh, okay.
So, I can send you the details. So I'm hopefully trying to put together a peer report on this work that I'm doing, and I will have a summary of the buckling model in there.
Yeah, that would be actually great, and also actually that would be a great contribution also to OpenSea's users and all that.
Yeah.
So I think I'll email you, and maybe I can get that reference from. Yeah, thank you.
Looks like we're almost at 2:30.
Yep.
Yeah.
So Amit, we had a full session discussion at 2:30, so that's good.
Yeah, I'm disappointed I got no questions, or Aditya got no questions. So
You mixed up steel and concrete in here. Most of the presentations were on concrete. Huh?
yeah. All right. All right. Well, good to see everybody.